Good morning all. Today in electron devices and circuit theory, we'll solve some problems on the Zener diode. Okay. So previous lectures we have seen what is the Zener diode, what is the major applications of Zener diode. Okay. Today let us see certain problems on the Zener diode. So here you have the symbolical representation of Zener diode. So Zener diode is having two terminals, anode and cathode. It is a heavily doped PN junction which is used in the reverse bias condition. Okay, and the major application of your Zener diode is as a voltage regulator. Okay, so we'll see for the circuit. Here you have the circuit with the Zener diode. So here for this circuit, what you have to, so this is the circuit which you have. So here you have to, for the circuit shown below, you have to determine the output voltage. Okay, output voltage you have to determine. Similarly, the voltage drop across the series resistance, voltage drop across the series resistance you have to find, and also you have to find the current through the Zener diode. So here you are having a resistor with 5K. So 120 volt supply is here. So this is your current which divides into two. So one is your load current. Here you are having the load is acting as a 50 kilo ohm, and here you are having the Zener voltage is given to be 50 volts. So you can replace the same by a voltage. Okay, the voltage by the 50 volts. So first is what is the output voltage. So how to determine the output voltage across the Zener diode. Okay, so for that output voltage will be equal to, this is the formula. So it is the load resistance into the input voltage divided by your total resistance. Okay, so in the circuit itself you can see what about the load resistance. The load resistance value was given to be 10K. Okay, so this 10K you have taken here, and the input voltage is given to be 120 volt. So multiplied by 120 divided by total resistance. Input resistance you have given to be 5 kilo ohm, and the resistance here RT is given to be 10 kilo ohm. So finally you will be getting the input voltage output voltage is given to be, it is 80 volt. You can determine the output voltage. Okay. Next, the question asked is, what is the voltage drop across the resistance R? Okay, so voltage drop across the resistance R means what here? You have voltage drop across the resistance means it is the input voltage minus, because here the circuit you are having the input voltage. Okay, so the input voltage minus the Zener voltage. So input voltage, you know, it is 120 volt, and Zener voltage in the circuit itself it is given to be 50 volt. So 120 minus 50 volt gives you a summation of, it is a 70 volts. Okay, finally the load current. So what about Ohm's law? So based on the Ohm's law, what about here? Ohm's law you have your in any circuit. What about in any circuit we are having the voltage V will be proportional to your current which is flowing through it. So it is V is equal to IR, or I is equal to V by RL. So the load current here, the load current IL is given to be VZ by RL. So VZ you have 50 volt divided by RL is equal to 10 kilo ohm. So here you will be having it to be the current value will be equal to 5 milliamps. Okay. Now the current through the resistance. Okay, current through the resistance. Current is what? So from the same Ohm's law formula. From the same Ohm's law formula, what is the value of current? Current is equal to, current is the voltage divided by RL. So current through 5 kilo ohm resistance you have to find out. So already you have found out the voltage to be 70 volts. So 70 divided by 5 kilo ohm is equal to 14 milliamps. Okay. So now the applying. So from the circuit. So what about the total current? Total current is splitting into two, IL plus IZ. So therefore Zener current can be found by total current minus of IL. So it is equal to 14 minus 5. 14 minus 5 you are getting it to be 9 milliamps. So your output, that is the applying Kirchhoff's first law, your output current is equal to 9 milliamps. Okay. So this is about the Zener current or your output current or current through the Zener diode. Current through the Zener diode is given to be, current through the Zener diode is given to be total current plus load current. So here you are minusing the total current from the load current. When total current is subtracted from the load current, for total current you have already found out it to be, here you have found out it to be 14 milliamps. So 14 milliamps minus of this one you have found to be 5 milliamps. So 14 minus of 5, it will be giving the answer to be 9 milliamps. Okay. So the current through the Zener diode is found to be 9 milliamps. Okay. So I hope you are clear with the problem. Okay. So the second sum we will go. What value of series resistance is required when 3 10 watt, 10 volt, 1000 milliamp Zener diode are connected in series to obtain a 30 volt regulator output from a 40 volt power source. So we will draw the circuit. Okay. So here your input is 40 volt DC power source is there. Okay. So here how many, the value of the series resistance which has to be added when 3, this rating is given 10 watt, 10 volt, 1000 milliamp Zener diode has to be connected. Okay. So here we are connecting the 3 Zener diode is connecting. So it is connected across a 45 volt. Okay. So here you have to find the value of the resistance to be added, so that you will be getting the output voltage as the 30 volt. Input voltage is given to be 45 volt and output you should get to be 30 volt, and here you have given the range of the Zener voltages which is given, and the value of the resistance which need to be added has to be found out. Okay. So voltage rating of each Zener. So you have given. So each Zener is given to be, from the question it is 10 volt. Current through each Zener is given to be 45 milliamps, and input we know it is an unregulated supply, so it will be equal to 45 volt. Okay. So the regulated output voltage is what here you are having 3 Zener diodes which is connected in series. So when 3 Zener diodes are connected in series, the voltage will be equal to 10 plus 10 plus 10. So you will be getting 30 volt. 30 volt will be the voltage. Okay. So now we are assuming R is the resistance which is connected in series. So what about the voltage ma? So it will be equal to EI minus of E naught. So so voltage across the resistance, because your input voltage is 45, output voltage is 30, in between that you have a resistance R. So the voltage drop across the resistance R can be found by subtracting the input voltage from the output voltage. So you got it to be 15 volt. Okay. Now for the resistance, what is the value of the resistance? The value of the resistance can be found out by, so again voltage drop across the resistance you have found out. You know the current across the Zener. Current across the Zener is given directly in the question. So voltage drop you have found out. So value of the resistance can be found out by 15 volt by 1000 milliamps. So it is equal to 15 ohms. Okay. So I hope you are clear with. So here you are applying the Kirchhoff's laws. Once we are applying the Kirchhoff's law and the Ohm's law, we are getting the answer. Okay. Thank you all. Hope to see you in the next video. Thank you.